Let's take a look at the problem of missing data. Oftentimes when we're doing either studies or when we're building operational decision support systems, we're plagued, quite honestly, with the problem of missing data. Your IT folks come back and say, well, the reason the data is changing, that the stats are changing, is because we have missing data. And it really is a significant issue. It's very hard to manage. And it's something that really has to be taken into account early on in your project so that you can avoid significant issues later. But where does missing data come from? Well, here's a couple of examples. First, registration. When a patient goes in to be registered, it's possible that data is not collected on certain demographic variables, or even in the clinical intake process, there may be missing data there as well. Survey data is particularly notorious for missing values. You might have patients fill out a patient satisfaction survey. In that survey, patients will answer many of the questions, but not others. Sometimes it'll be consistently done where if there's a particular question that for whatever reason is later in the survey and people just don't get to it, or it may be more random in response. Either way, you end up with holes in your data. A big one comes also when organizations merge or either through takeover in acquisition, or even if they just simply merge together two existent medical record systems where you have to flow data from the old system into the new system. Oftentimes data is not pulled forward, and that can create gaps in the data. And that's always expressed in null values in the data in a relational database system. Down below, if there's a missing value in a field, it's typically characterized as a null value. So what does that mean to decision support, particularly in clinical and operational decision making? Well, clearly, if you've got missing data, if you as a human were going to make a decision and you found that there was missing data necessary for you to be able to make a well-informed decision, you'd stop and you'd go back and you'd try and get that data either by directly inquiring the patient or whatever, but you want to fill in that null value so that you've got a complete record about that patient so that you can make an informed decision on some operational or clinical activity that needs to happen. We don't really have that luxury when we're thinking about computer systems, because the decision support capability, whether it's in the form of the system right now trying to guide you to a decision, say with an expert system, or trying to help make a prediction on what interstitial lung disease patient might have. Either way, the computer relies on the availability of that information to be able to either process its rules or to be able to create statistical algorithms that will make predictions effectively. So let's just talk briefly about how you might, in both of those scenarios, handle this and give you some idea about the complexities involved. So let's take the first example where we talked about, just mentioned rule processing, where I've built several hundred, several thousand rules already to be able to guide you towards a particular decision. Now my problem is that those rules were built by smart experts who were looking at data and, when available, were able to simply say, if this, and this, then that's what I need you to tell you and potentially recommend that you do. Well, the issue there is now, of course, some of that data is missing when I go into production, right? And what do I have to do to accommodate that? Well, I could create a series of handling rules, data exception handling rules, where I could, for every single variable that I have where rules are applied, I could go back and say, well, do this, and this, if the data exists, If the data doesn't exist, and in combination with other factors that might influence how I respond based on that data not being available, then go ahead and do that. Well, that means I've got to create many rules in addition to my fundamental operational clinical rules in order to handle that missing data. It gets very, very complex very, very fast. If I'm looking at trying to create predictions using machine learning and trying to allow the computer to build models off of historical data to predict futures, I have a slightly different problem, right? The computer isn't going to stop because there's null values. We might be able to create some statistical algorithms up front that could identify if a variable is consistently null, it just doesn't exist for certain parts of my population. I could potentially write some kind of feature selection algorithm that would prune that variable out of the machine learning so that I don't use that going forward. Well, but what that does is it says I can't leverage that variable at all, even when I know the values for it. So I might be able to I might have to do something else. I might have to see, well, is there a way to partition my historical data so that when I have that variable value for certain members, I do this and create a machine learning algorithm off of that, which would produce hopefully very good results. And then I take the other patients where I don't have that value and I create a predictive model, and that might be very successful, but probably not quite as good in its likelihood prediction as the model where I have the data. And then I could apply those models on existing people today and predict likelihoods. When I have the data, a little bit more favorably. When I don't have the data, maybe not quite as well. But either way, it's super hard to do that. Somebody has to be sitting down and thinking through what data is available. How can I use it? Do I address it up front and disallow records to flow in? If I do let the records flow in, do I partition them? There's a whole variety of other ways that I could address that. Basic message here is that null data, missing data, is extremely hard to handle and oftentimes very much not appreciated by the business community that the systems are trying to support, and really, really needs to be thought of as a business problem. How do I better collect that data? What do I do if that data is missing? How do I handle it with the technology so that we can come up with a reasonable implementation to enable my decision support?